We just sent Marcel. He has the talk.
I do have a talk. So
Go!
Okay, yes. So I'm glad that I'm going to do this in English, if that's okay with everybody. Okay. I'm glad that the cool talk is already over. So everybody's relaxed and we can just sort of get on with a little bit of tech talk. So my name is Marcel. I have my own company, MetaObject. I do a little work for Six Wunderkinder, which is cooler than I expected. And I'm also associated with the Hasso-Plattner Institute. And maybe some of you have been following sort of the recent Twitter and blog eruption about, oh, we should replace Objective-C. This is my contribution, which has been in the works for a long time. And sort of my background, I've been doing Objective-C for a little over a quarter of a century. I think I have a perspective on, why it's great and that we shouldn't break it just for the heck of it. So objectives for Objective Smalltalk were, to be precise, I wanted to have better scripting than I had at the time, and it started a long time ago. It seems to me that Objective-C has sort of grown a bit long in the tooth, and we could do something better. And I'm going to explain why it's Objective-C Prev and not Objective-C Next. And the third part was more researchy in terms of software architecture, building bigger systems, having a more expressive way of building our systems. And so the scripting part first, what I would like there is, we have this Unix shell, and I think it's very productive and it's a cool environment, but it doesn't really integrate well with the rest of our Cocoa APIs. It'd be nice to have a Cocoa REPL, read evaluate print loop. It's also really nice to have custom REPLs, so you have some functionality that you've put together, and for example, I don't know, you know how to interact with XML files or PDF files, and just have a REPL that works with that, and just be able to customize that. And I'm also really into live programming. So without much ado, let's skip to the demo. And gotta hide this, and actually I'm gonna make this a little bigger. Yep. So I said I want a REPL, and there it is. It does 3 + 4, so therefore it's a Smalltalk, right? It can do hello world. Amazing. It can do sort of Smalltalky things, right? Concatenate 2 strings. But it can also do this in an Objective-C way. So we have hello string by appending string, right? World. And oh my god, it actually works, despite the fact that it's a demo. We have things like arrays, but we also have things like intervals. Let's see if I can... No, that doesn't work. Okay, standard out, print line. There we go, 1 to 10. Then we can do, of course, we can do iteration in the Smalltalk way. Standard standard out, print line. And yeah, everybody know the website, fucking Objective-C block syntax or whatever it's called. I have to look it up every single time. It's your homepage. All right. Thank you, because I use it.
I use it as my.
Oh, you use it as your home. Oh, okay. So anyway, yeah. This is what blocks could look like, right? There is another way of doing this, which is if we have a collection, right, we can do this. And we want to add something to this collection. Of course, it says error, but we have this thing called higher order messaging, and then we can do it even simpler, right? We could have done this with a block. That would be the standard block syntax: a + 5 or 4, And there we go. Same thing. Let's see, what else did I want to do? That's sort of the basic language syntax stuff works. If I want to look at the local directory, I just say file : // and it gives me the local directory. If I want to look at a file in here, I say triangle.sgsh, and I need to spell correctly, and I get the file. And so I can do file manipulation in a very natural way. Okay, that's sort of basic language stuff. I also want to do live coding, and I have a little graphical thing here. Is that the one I want? Yeah, let's start from scratch. So let's see. We have a context, and we want a, can you see this?
Yeah.
Yeah, okay. So we want a rectangle, and we want to fill it, and there we go. That's located really a little bit at the bottom, so let's move it further. Let's center it. Oh, no, it's too much. Okay. Let's change the color. This is very long-winded. It needs to be better. Now we have a new color. And let's see, somewhere here I had something, so let's not do that. That's, yeah. Sketch view. So we need an offset. Let's say, what I want, 10 and 10. I have a blur factor, 2 color. Oh, colors suck. So let's color. That's going to be a red shadow, but that, well, what, who cares? Hey, block syntax, right? There we go. That's a shadow. It's a bad shadow. So that's better. Blur 5, 10, and let's make it to bring it to the bottom, right? Minus 20. I don't know, something like that. That's a shadow. So that's live coding. As you saw, it's evaluated on every keystroke. Actually, that's a great way if you're building a language to see all the bugs in your implementation, because you get weird syntax errors all over the place. And I think, well, and also there's the API. This is really just talking to Quartz with a small wrapper. And mostly it just passes things pretty much straight through, except it actually takes advantage of blocks. So I have another example here. I don't know, how many have used Quartz patterns? Whenever I started looking and say, oh, I gotta, here's a callback I have to write, and here's a structure I have to fill, and that's just really a block, right? So I was saying I need to put, where do I have the pattern? There. And that's like that, and now I have a pattern. And I just took the code for drawing, and I just put it in a block and say that I want to set the background color to this block that I got, and there we have a pattern. Okay, that's that, and back to slides if I can find them. Yeah, whatever. And so that was the scripting part. So the second part is Objective-C again has gotten a little bit long in the tooth, and one of the reasons is that it's a crash, right? We took Smalltalk and we took the C programming languages, crashed them into each other, and whoop, there we go, Objective-C. If you go back to the source, Brad Cox's book, you will find there were actually two reasons he gave for coming up with Objective-C in the first place. He loved Smalltalk, but it had two problems. One, the performance at that time wasn't really acceptable, and the other part was simply interoperability. It just doesn't talk the same APIs. It doesn't interact with the platform. And Objective-C solves these two problems with the same basic invention. Is that, well, we just integrate C into the language, and what to do there, we have it. Now, those two things don't really matter in quite the same way anymore, right? Because certainly performance has changed. If you've ever run Squeak, as traditional bytecode interpreter, and that was perfectly fine 10 years ago, and right now it's blazing. And on the other hand, I don't know if anybody's was here at my performance talk about a year ago or something. Actually, if you use Objective-C in the way that people use it today, it's actually slower than most Smalltalks. So we don't really have that anymore. And so the question is, can't we just start simplifying this a little bit, right? Because when we want to interact with objects in Objective-C, it gets kind of messy, right? I mean, okay, we don't need to do NS number with int anymore, but at bracket 3, that's how we write constants. How about 3, right? And of course we can't do arithmetic. Not in a reasonable way, unless we use primitives. Then that works fine. This looks nice. Why can't this look just as nice, right? Yeah, we already talked about block syntax, right? What's that, right? It's ridiculous. Sorry. And well, why can't we have it like this, right? This is Smalltalk syntax. 3 plus 4, that's A, and then if we want primitives, why can't we just simply say, same syntax, we just added optional type annotation. And then, well, we saw the block syntax. That kind of looks nicer, I think. So that's the basic idea. And so apart from scripting, what I want is I really want a replacement language for Objective-C. That must be a peer. So that rules out a lot of the other languages that we have. For example, if you have, Ruby, it can't really be a peer to Objective-C in many ways. Even just the syntax is different. We have to map the selectors. And if you have something like FScript, it's not really a peer. It's a scripting layer on top, right? And one of the first things I did when I started with Objective Smalltalk is I made sure that you can write methods in Objective Smalltalk that can be called from Objective-C, and you can't tell the difference. Again, interoperability, but we wanted to start doing better, and we saw the REPL, and we saw that we can do a little bit of Unix scripting, and we can sort of start mixing up these things. Because before, if I had a something that was more Unixy, I either had to go, NS file manager, and that's really verbose and ugly, or if I wanted to do it nicely, then I have to suddenly, if I want to interact with scripts, I have to use an NS task. That's not really nice either. You get all this friction because you have these different systems they're interacting that don't really want to interact, and I just want to lower that friction as much as I can. And part of that is, obviously, at some point, static compilation. There is a sub-project that does that. It's not finished yet. So another demo for just interactivity. Let's see, where do I have my stuff? There's a small tool. It's View Builder. It's kind of like a it's a really primitive Smalltalk class browser-like thing. So you have classes on the left in the browser, then methods. And the method text down here, it talks via HTTP to a client application. So discovery is via Bonjour, so it's actually connected to an application. right now, which is in the simulator, which is a little PDF viewer thing that I have. And I'm going to change something here. So I'm going to make this true. And suddenly these things appear in the running application. I can move them about. Yeah, things move about. And you can, prototype your graphics, your drawn coded graphics in something like Sketch View, and you copy paste them over here, and voila, it all works just beautifully. There's no magic and whatever. So that was that demo. So that was the second part. That was sort of Objective-C, bring it back to the roots. The third part is architecture. And that's more of the researchy bit, where I'm also doing my PhD thesis on this. And this is the idea that actually, well, maybe we can, how can we develop this, right? And the basic thought was, well, we can really apply this polymorphism idea, which has worked so well for our objects, to the language itself, right? So we make messaging flexible. We make data flow assignment flexible. We make identifier lookup flexible, these three things. And polymorphic identifiers is one part of that. That's in the language right now. I held a got a paper accepted at Dynamic Languages Symposium at IPSLA last year. So we can see a bit more of that. Then obviously higher order messaging, which I also demonstrated a little bit. That's longer ago. That makes messaging flexible. And the final thing is sort of data flow stuff, right? Think of Quartz Composer. That's starting to be there, but it's not fully there yet. Where you just hook up things. Unix pipes are similar, that sort of stuff. And did I? Yeah, so this is kind of a class hierarchy of language components, right? So if we take the basic idea from software architecture, that all these things that we use to connect our pieces, something like a data flow, something like a message, these are connectors, right? So we say, well, we have connectors. Then we have messaging, and we have data flow connectors, and we have sort of variable access. And if you take something like Smalltalk, it uses bits of these, right? So it uses Smalltalk message, and it knows about local variables, it knows about global variables, instance variables, it knows about assignment for data flow. And what this shows really is that these languages are very related. They're not totally different. And actually, if you just go to a slightly different point here, right, you have Unix shell, right? It has procedure calls, it has local variables, it has sort of environment variables, it knows about files, it doesn't know about assignment, it knows about pipes, so it knows a bit more data flow than Smalltalk does. And the question there is, why should this be in different languages? It seems that, again, the differences are really small when you actually look at it in detail. Part of the answer to that is polymorphic identifiers. Basically, when I thought about this for a while, it dawned on me that I had to actually redo naming, because names in programming languages are a concept that is really, really solid and hardwired. Right? You can't really affect how names are interpreted, which causes us to use dictionaries all the time, right? We have and key value coding, because we actually want to do something slightly different than an assignment, but we can't, not with the language, so we build these structures around the language. So we have a accessor that calls, what's the KVO stuff? Will change value for key, did change value for key. Somewhat ridiculous. Again, also, we have multiple ways of accessing external data. There's NS data, data with contents of file. There's NS image, image named. There is NS bundle. Then there's the URL variants of all these. But all these things just retrieve resources. And I can't, also if I want to change something, I can't, right? I mean, if I say, well, this used to be on a server, now I want to test it, I have, maybe even in memory or from a file system, it's completely different. APIs are completely different. So let's see how this works in practice. So if I have a variable a, right, I can also write this like this, and as a URI, right? So, but I can also say, do we have? Oh, I don't have network. Well, you already saw that I can use files, right? The same way I can say put this in a variable. Dir is like that, and then I can say dir. These things become interchangeable, and oh, wait a second. Oh, I don't even know the wireless.
It's GB79 Gast.
Yeah, okay.
Come in and find out.
Thank you. You will need to change that. If we publish it, you will need to change. Okay, so Amazon.com, right? I can just write that down, and there we go. And this is just the programming language. It doesn't make a difference. And if I want to download this, I write, file temp Amazon is equal to this, right? Or and if I then it's obviously the same thing. I can say, what's the length of that, whatever. And distinctions are just broken down. It also works the same with, for example, dictionaries and PDF files, XML, that sort of thing. It just, if it has a hierarchical structure, which most of the data that we deal with has some sort of hierarchical structure, you can start accessing it like with paths. That was actually a technique, I call it in-process REST, which we used in a BBC project, was really successful. Replacing a legacy system that was having really hard time keeping up with fairly low pressure demands on producing new data, a sports feeds application. And what we did is we just made it all in memory, and with a event poster architecture. Right, and this that was also one of the motivations. Like, well, it would be nice if you could actually write something like that directly. Of course, with this particular, that was written in Java, so we had to use strings everywhere, right? And then you start doing string processing everywhere. Why should I be doing string processing? I'm not really interested in, I want to have identifiers. Okay. Yep.
What kind of data type is this? Is it just untyped and a structure, or is it in the understood data type that you store all this in, like the website and the file system?
There's actually a fairly deep structure. You have this is the scheme that does a mapping of what a scheme prefix syntactically actually then maps to. And there's a scheme provider, and the scheme provider then has ways of accessing items by path. This, of course, it's scheme specific. They can be composed. There are, for example, there's a cache component. You just hook them up together. Your typical HTTP scheme provider will actually be a raw HTTP scheme hooked up with a couple of caches and maybe converters, autoconverters for data types. And then you actually get the output. And actually, I can show how that works in the HTTP server. So that's a little HTTP server. First line loads a library framework, and then I create a new scheme, which is the site scheme. In the which is also called, which actually has the scheme site, and then I can just store something in there as a URL, and then here I set up a type like that, right? So I set the scheme, and that goes directly to the HTTP server, and then I just start it. That's one part of it, and then of course you need references. So you have first-class references that know how to talk to their scheme provider. Does that kind of answer the question, or?
I'm probably not 100% following, but
Sorry. Okay. Yeah, there's a lot to.
I think you're really deep into it.
Yeah, probably. Okay. I guess I should have it. Maybe some more talks with sort of parts, because it's a lot of stuff.
So you're basically building your own language.
Right, which I mean, it starts out as Smalltalk, but a Smalltalk that doesn't. That's not a classical Smalltalk, but a Smalltalk that runs on Objective-C with all the compiler stuff, and then you actually start breaking it up and taking parts and making it possible to recombine them to get various other language types that you would want to have at different points.
But in the end, you still compile to the same output that Objective-C compiles to.
I do not use the Objective-C compiler. Right now, the scripting part is just an AST Walker interpreter. So it just builds the abstract syntax tree and interprets that. There is a native compiler based on LLVM in the works. It's not done. So at that point, I would consider it sort of parity. Then you can really develop on this equal footing with Objective-C. Right now, all the Objective Smalltalk is always interpreted, even if it's communicated to the other application. Although, again, from a user, for many types of applications, that doesn't make a difference. For example, if you're starting an animation that takes a second, executing that code, even though it's incredibly slow, it's a really, really slow interpreter. It's, I think, probably the slowest one in existence. But it doesn't really matter when you're starting when you're defining an animation that lasts a second. So, yeah. Let's see. What else did I want to talk about? Oh, that's right. Now that we have this, let's actually run this, right? So HTTP server, right? So localhost. There we go. It starts it. I can say site slash CocoaHeads equal totally cool, obviously. Yeah, I can't. Like that, right? That's better. And I run there, and I reload, and it's there, right?
Awesome.
and the thing is, it decouples sort of the HTTP serving thing from the data model, right? So usually you have, I'm now in HTTP server land, and we plug into this. What this does, it says, well, actually, I have these things called scheme providers, and I can talk to them in different contexts. I can use them directly from the language. I can, there's another project here that, I can mount them as a file system if I want to. And I can use them as a client or as a server, and then I can just hook them up and say, here. So if I have it, I also have a PDF shell. PDF shell down. Don't even know what that is. PDF, no page count, I think. 15 pages, whatever. PDF pages last object, right? That's a PDF dictionary, right? And of course, then I can actually do it like this: PDF, pages, 1, 2, and I can keep going, right? So I say contents. No, contents, yeah. Yeah, it says that's a reference. 0. And actually, reference value, and I got the PDF stream. I can navigate, and I didn't really have to do anything at that point anymore to navigate, because I have something that is a hierarchy. I can traverse it, and I haven't tried it, and I'm not going to try it now. But damn, I should really be able to just say HTTP server serve me this, and it'll pop up. Yeah, so.
But how, when you want to dig into the details of an HTTP server, you have to manipulate the scheme, or if you want to manipulate the way how the HTTP server works? Or where would you do that?
What do you mean with manipulate the details of the HTTP server?
For example, our backend guys that don't use HTTP, they use Nginx, or even custom web servers that are really reduced to the bare minimum just to deliver stuff.
Right. So this is actually so the web server I'm using is based on libmicro-HTTP, and if I actually start, if I say work, everybody know the WRK benchmarking tool? It just totally rocks because it can hammer your web server like nothing else I've ever seen. And so I say minus count. No, that's connections. So I want 10,000 requests, connections, local host. Hi. Yeah. Connection. Oh, I need to restart the server. Yep. All right, so 27,000 requests per second, and this is running over HTTP.
Sorry, I was not questioning the performance.
No, but in terms of this is also a naked web server, so you can, of course, you can. Nginx and servers like that, they can run in proxy mode, so they'll forward the connections.
But this web server is built into the scripting language.
It's not built in, no. It's loaded. So here, that's a framework. So that's the way to load frameworks, and Objective HTTP is just this framework. It's a small wrapper around libmicro HTTP. It's a GNU embedded web server, which works really nicely.
Whatever you want.
And you can use something completely different, and you would need to somehow map what you get from the web server, what that wants, to what your scheme provider. But once you have mapped it, any other scheme provider would work just as well. And for example, that we have env home, right? And if I want file, how does that work? And home. There we go, right? That's my home directory. So these can nest. Okay, and
is the concept like I think there's this operating system where everything is a file or something, so like in Objective Smalltalk, everything is an URL, or
everything. So every entity can be referenced by a URL. So we take this thing about the universal resource identifier seriously, and we say, okay, everything in our language is accessed by URI. And if you can find some kind of way of doing a scheme provider for it, then you can access it naturally, right? Because what I found anyway, I don't know if you find the same thing, is once I have something that is slightly different than the language, what the language provides, I have to sort of abandon completely what the language provides and create my own pseudo language on top, right? Which is what KVC is, right? That's its own string-based pseudo-language. And of course, strings are awful, right? Because the compiler can't check them. They're really, really slow, especially if they're NS strings. And you start writing your program in a different language, and then it becomes just clutter, right? Everything is value for key. If you want it consistent, or you have it inconsistent, which also isn't really nice. And this is the way of saying, well, if we have something that's slightly different but actually fits that model, then we can import it back into the language.
Does the, I guess like the runtime, like during runtime, do you have a way to configure your schemes or like manipulate them?
Yes,
anyway?
yes. So going back. So I have a scheme, and that is the mapping of all the schemes. So if I want to have a new scheme that's, and there's a default scheme, so if you see something that doesn't have a scheme prefix, then it uses that particular scheme. So if I want to, scheme CocoaHeads is equal to scheme file, and now I can say CocoaHeads dot, and there we go, right? And the basic idea really is that you will define your custom schemes that are have meaning for your application, right? That signify what your model is. For example, there's a great note by Roy Fielding about what he would like as an IETF scheme, right? And what it should do, it should first look in his local directory where he has the RFCs that he keeps. Then it should look at the one server, and then it should look at another server, and then give up, right? You can build that thing very trivially with what Objective Smalltalk provides. And again, if you have a database scheme, right, that should be easy. There is I haven't done that yet. I've hooked up a couple of databases. There is a project out there somewhere which does a sort of automatic mapping of relational databases to HTTP URL schemes. That sort of thing obviously would be really wonderful. Furthermore, what's not in there is, and what would be really useful, I think, would be to extend the identifiers so they actually take some of the XPath syntax. So you can start doing queries, and it doesn't matter, right? Because right now it's like, okay, if I query XML, it's XPath. If I query SQL, it's a database and it's SQL. If I query something else, it's whatever I can come up with. And why should that all be different? These are all tend to be hierarchical data sources. I should be able to just traverse them using some common syntax. And since XPath is embeddable in a URI, this is workable.
But SQL isn't hierarchical.
It's sufficiently hierarchical. I mean, if something is even, it's less hierarchical. And a lot of, in my experience, actually, when you use relational databases as backends for your data model, you tend to actually start building hierarchies within the SQL by having the point self-references and stuff like that. And again, you can switch it around. You've decoupled your data model from a particular implementation.
The part where you showed the iOS app, where you could somehow inject the code. This is so runtime is running in the iOS app, interpreting the
there's a library in there, and there's an HTTP server running in there, and it publishes itself via Bonjour, and it says I can do these things, and connects automatically, and I'm at 6%. Yeah.
2 minutes. 2 minutes. So get through your slides.
I think the slides are pretty much done.
Okay.
Let's see if I can find my.
So do you think you can push this app to Apple? Will it go to review?
I actually saw one app you're running on. Yeah, thank you. What the? Can somebody give me power? Wow, that's very. So that was the demo. I can make this bigger, I guess. Can everybody read that? Yay! Q&A. Thank you very much. There is code. Apparently, it doesn't compile, so we'll need to fix that for other people other than me. You can follow me on Twitter if you really want to. Again, these are some of the sort of the bullet points. You want sort of scripting, compilation, objects, Unix. You want to hook them all together without all this, nasty boundary type of problem. Software architecture, I really think it's the future, and we have some of that with polymorphic identifiers, high-order messaging, and the static compiler is in progress, and of course, feedback and code and all sorts of stuff is completely welcome, and questions. Not that we haven't had any.
Maybe just before your battery runs out, can you quickly show like a scheme or examples?
Oh, okay. Thanks. You want to see actual code? Oh my goodness.
I'm just curious. Like,
and you should say the QuickTime movie because.
Yes.
Yeah, maybe stop the QuickTime movie so that.
Right.
I guess it already stopped itself.
It has?
Yeah, I can't see the stop icon at the top anymore, so.
Well, it might be the menu that is big.
Yeah? Oh yeah, there it is. Next to Twitter. Next to Twitter.